Probably wondering what I'm making a video about and why I'm making a video about it. It's spring break, we're supposed to be relaxing, but we're not going back, are we, for the rest of the spring term? So we're stuck at home, and to keep me from going crazy and totally losing it, I decided to make this video because when we go back, we're going to get started right away. So I thought, why not make something that'll help us sort of make sure that we remember everything from last week and that we didn't forget everything. And you're like, oh no, a 50-minute video. I'm gonna just go over like the basics of basics of basics. The 1, 2, 3s that should jog your memory so that you can remember everything. And if you want to watch this just 15 minutes before class on Monday, then go ahead, because maybe that'll help you, that'll jog your memory. So I'm just gonna go based off all our sort of midterm sheets and study guides and all that kind of thing. But I'm just gonna give a quick run through from chapter 1 to what should we be ready for on Monday, what we should be ready for and remembering. And if I'm talking funny, it's because I'm tired. I didn't sleep much. 4 hours of sleep doesn't help. So, let's see. In chapter 1, we did just body organization. So, big things there in the midterm that was supposed to be asked was levels of organization. We have 6. The chemical level is the smallest. And it's non-living. So, it goes from smallest to biggest. It goes chemical level, cellular level, which is the first part that's living, then tissue level, organ level, system level, organism level. Against chemical, cellular, tissue, organ, system, organismal. And you probably can put that together, you probably know what that means. So then life processes. So what does that mean? Metabolism, it's basically all chemical reaction and processes that happen. That's it, that happen. And what's catabolism? There are 2 types in metabolism, catabolism and anabolism. So when professor says catabolism, it's destruction. Anabolism, it's building. So it's basically anabolism is the opposite of catabolism. And there are 6 different life processes, and then the definition of homeostasis is basically equilibrium of the human body. So based on those positive and negative feedback loops, which we just finished up in nerves, because that's what the positive and negative, that's how they work, based on nerves. If you remember how the positive and negative loops work, positive is when it reinforces, negative is when it says do the fucking opposite. So like I said, affector neurons, they take it away. So affector starts with an A like alpha. So I remember affector is the afferent neurons. That's what the dendrites take in. So afferent, I remember A for away. So it goes up, that goes up to the brain. Brain says, okay, what do I do? Integrates it, brings it down through effector neurons to mainly somatic motor neurons. And that's effector neurons, which means E for effect. You'll get the idea. You'll make something up. So those negative loops. Negative is like blood pressure goes too high, vascular dilation. Positive feedback loop, childbirth. So that kind of thing. So there are always homeostatic imbalances. You probably know a bunch of disorders of homeostatic imbalances. So let's see. You probably know a lot about the anatomical terminology, directional terms, planes and sections, body cavities, vertebral cavities, thoracic, all of that good stuff you probably know about. So I'm not going to waste your time by going through all that. It's like, I don't want to either. I don't want to waste your time. So let's see. Yada yada yada. So like I said, there are 6 levels. So chemical level, if you remember, atomic numbers, number of protons, positive charged, neutrons, no charge, electrons, negative charge. And an ion is when something becomes positively charged or negatively charged. So that's important for the nervous system when we start talking about it again, especially in the brain and the spinal cord. It's important to know when something's positive or negatively charged. So that's important. And so bonds and chemical bonds, ionic bonds, that's a giving or taking of electrons. Because remember, protons and neutrons are in the nucleus, so they're stuck in the middle, and then the electrons circle it, like orbit the thing. Well, there is no nucleus. It's in the center, and the electron, there is no nucleus in the chemical. Sorry, I made a mistake. Chemical bonds, protons and neutrons are in the middle, and then electrons circle it, orbit it, like the planet Saturn. Think of it like that. So ionic bonds, they give or take electrons to make stuff stable. So a positively charged sodium ion or a negatively charged chloride ion gives or takes electrons to make sodium chloride, which is known as salt. We eat salt. So that's how that works. Covalent bonds, sharing of electrons. An example is water. We drink water. We need to be drinking a lot of water right now. And that's inorganic. Why is it inorganic? There's no carbon. Anything with carbon is organic. Well, 95% of the time. If you're hearing all sorts of nonsense in the background, that's just my family. Sorry. Anyway. And what's hydrogen bonds? There has to be hydrogen in the molecule, and partly charged negative and a partly charged positive ion. They combine with using the hydrogen, and it's weak, but usually they appear in very big molecules, so that makes it stronger. So, yeah. So, chemical reactions, potential, it's the energy stored. Kinetic energy, the energy is associated with the matter in motion, and chemical energy, it's potential energy stored in chemical bonds. So it's not rocket science there. Well, actually it is in chemical bonds. That is rocket science, but not too hard. So exergonic reactions, it's like a explosion, like a boom. Endergonic reactions, inward, so they absorb more than they release. All of that's great. Remember, solute, that's what gets dissolved, and a solvent's dissolver. So basically, water dissolves salt, so salt would be the solute, solvent would be water. Boom, we're done there. So, know a lot about properties of water. There's a lot of properties to water that we should know. Acids and bases, pH. So the lower the pH goes 0 to 14. The lower the pH, between 0 to 6.9, it's acidic. 7 is neutral. 7.1 plus is alkaline or basic. So, don't ask me to do the math of how that works. I cannot do math. So too much coffee, basically, like I drink about 24 ounces a day. Too acidic. I do get heartburn. So yeah, like I said, they're organic compounds, monosaccharides, disaccharides, polysaccharides, carbohydrates, lipids, have triglycerides, proteins with amino acids as their monosaccharide. So know the monomers for carbs, lipids, and proteins, and because triglycerides are not the only lipid, there are phospholipids and types of sometimes a few types of steroids. But yeah, saturated, unsaturated triglycerides. So a carb is a monosaccharide that's a simple sugar and is 3 to 7 carbon atoms. So you have glucose, fructose, galactose, and then of course 8 carbon atoms and forward it's a disaccharide, then polysaccharide. And if I'm bouncing around a lot and you need to replay stuff, sorry, but I tend to do that because most of the time I'm bouncing around answering questions. But yeah, not that's besides the point. So hopefully that rings a few bells. Remember, in proteins, a new chemical shows up. Remember, in carbohydrates and what did I just say? Carbohydrates and lipids, it's just carbon, hydrogen, and oxygen. But nitrogen shows up in proteins, and then nucleic acids like DNA and RNA. You have carbon, hydrogen, oxygen, nitrogen, and then phosphorus, because there's a phosphate group. So you remember the properties of ATP, anaerobic phases and aerobic phases, and you should be good. And hopefully this is just all ringing a bell, moving you forward a little bit. So what do we have? Cell and parts of a cell. Okay. Remember, don't get caught out that there are only 3 major parts. There are 4. Plasma membrane, cytoplasm, nucleus, organelles. Organelles is the 4th one. That's important because I got cut out on that on the test. I'll be honest. Anyway, that's not funny. And remember, plasma membrane, phospholipid bilayer, hydrophilics, which is hydrophobics. Hopefully you remember everything. If not, please check your notebook. Exocytosis, endocytosis, cytoplasm, the difference between cytosol and organelles. Cytosol is the liquid part, organelles are the little things that do stuff. Nucleus contains the DNA and RNA along the nucleolus, which makes the RNA that does stuff. Protein synthesis, and on and on and on. So cell division, somatic cell division. We probably spend a lot of time on this. Phases of mitosis and so on and so forth. So I won't go on to that, but we probably will need to know that for the brain, especially division of nerves. So that moves us to tissues, which is also known as histology. So studying histology. Let's see. What's important? We need to know the difference between simple and stratified. Simple, 1 layer. Stratified, multi-layer. Pseudostratified, it's a trick. It looks like multiple layers, but it's 1. And you have squamous, cuboidal. Squamous is square, flat and square. Cuboidal is, cubed. And columnar is columns. They're the ones with the goblet cells. You have 4 types of tissues: epithelial, connective, muscular, and nervous. You probably know where everything goes. Make sure if you don't, go check that. Remember what tissue makes glands: endocrine glands, exocrine glands, unicellular glands, multicellular glands, the whole 9 yards. Know stuff about glands, especially since we did a lot of stuff about the integumentary system. This all sort of leads there. Histology goes a lot into the integumentary system. Ceruminous glands, they're in your ears. They make earwax. If you sort of pick at your ears and stuff falls out, that was caused by the ceruminous glands. So all integumentary stuff, ceruminous glands, your nails, skin wound healing. 4 things. Phase A, like the skin wound, you have your epidermis, then your dermis, then your hypodermis or subcutaneous layer in your skin. So yeah. So, and if it's a deep cut into the dermis, you have the inflammatory phase, migratory phase, proliferative stage, and the maturation phase. And those are the 4 phases of skin wound healing. So, yeah. Replay that multiple times because that's a tongue twister if you want to say that fast. So, know the development and wound healing. Know when you get burned, 1st degree, 2nd degree, and 3rd degree burn. Know how that wound heals. That's important. No germ layers, ectoderm, mesoderm, and endoderm. So that's important. And then know about muscle tissue and nervous tissue. And again, I think I already made a video about this, but then in muscle tissue, let's take a brief second here. Muscle tissue, you have skeletal muscle, smooth muscle, and cardiac muscle. Those are 3 types of muscle tissue. And then the fibers are fast glycolytic fibers, fast oxidative glycolytic fibers, and slow oxidative fibers. So there's a difference between fibers, a difference between tissues. There are 3 types of tissues, 3 types of fibers. So just be careful there. And now some cell junctions in histology, not like the neuromuscular junction in the muscular system, but the other type. And like I said, tissue repair. And let's keep moving. Like I said, 5 layers from deep to superficial of the epidermis: stratum basale, stratum spinosum, stratum granulosum, stratum lucidum, stratum corneum. You only have stratum lucidum in thick skin. So that's the tricky one. Remember that. Second to superficial, stratum lucidum, only in thick skin. And just know what tissues make the dermis and where. Know what releases certain skin colors. There's melanin, not melatonin, melanin. So you have that. That makes that brownish black. And then there are other ones. I think keratin or keratine. I don't know how you say it. But there's one that's sort of a reddish orange type, and then hemoglobin makes the reddish one that's blue. What did I just say? Reddish one that's blue. Hemoglobin makes the red color. Keratin makes the orangey color, orange yellow color, and melanin makes the brownish color. So there you go. No sebaceous glands where they are, sudiferous glands where they are, eccrine, apocrine glands. So remember, we still want to learn. Remember all that. We just want to know all that in case that pops back up. Like I said, how burns are repaired. Bone. Know the difference between axial and appendicular skeleton. That's number 1, because that will come back in the nervous system. I promise you. Bones. The functions of bones: support, protection, movement assistance, homeostasis of minerals, blood cell production, and yellow marrow will store triglycerides. Structure of bones. You have the bone shaft. Say, take a femur. The bone shaft is the diaphysis. The epiphyses, the proximal and distal ones, are basically the ends. The metaphysis is just like a little bit in between the two. Articular cartilage covers the outside. Periosteum, medullary cavity, endosteum. This should all ring a bell. Let's see, disorders: osteoporosis, rickets, and osteomalacia, arthritis, all that stuff. So that should all ring a bell. And axial and appendicular skeleton, remember which is which, why it's there. And don't get tricked, because there's some parts that seem like that's the axial skeleton, but it's not. Like your clavicle, that's not. Growth. How does your bone grow? The 4 layers. Like the zone of resting cartilage, zone of proliferating cartilage, zone of hypertrophic cartilage, and zone of calcified cartilage, all in the epiphyseal plate, which soon grows under the epiphyseal line. Know the order, know how it stacks up, and know what grows what. So know the structure of a one bone cell, like osteoblast, trabeculae, mm, uh, osteons, like lamellae, lacunae, all that good stuff, that you spend hours and hours and hours and hours and hours and hours and hours reading. Fractures, open fractures, green stick fractures, impact fractures, compressed fractures, Colles fractures. There are more than that on our list, but know that. And go to your lab master list if you want to know more about stuff, because there's a lot of good stuff on there. Matches good stuff on our study guides and stuff like that. Know how bone is repaired, calcium, how that affects exercise, and how bone sort of adjusts to that. So, yeah. So, yeah, axial skeleton, like I said, skull bones, auditory ossicles, which is in your ear, hyoid, ribs, sternum, and bones of the vertebral column. Those, that's your axial skeleton. And then everything else that exists that's a bone is your appendicular skeleton. So you got long bones, short bones, flat bones, irregular bones, sesamoid bones, sutural bones. Just know where you'll find what, and then know which joints you'll find where. So I don't think I need to go into that, because you should know that, and we spent a hell of a lot of time going over what's in our spine, what's in our head, in our skull, and all that stuff, what's in our vertebrae, what's in our the spine, what's in our sort of thorax, and all the terminology and stuff like that. So we're good there. And remember, you have 8 carpals to 7 tarsals. Carpals in your hand, tarsals in your foot. So you have a true and false pelvis. Know the difference between the true and the false pelvis. Know the difference between a male and a female pelvis. And yeah, that's something that should also be ringing a bell. This should all be jogging your memory. And as I'm talking, you should be sort of, oh yeah. You should shut up now, because I know this. That's what you should be thinking. But I'm not going to shut up. I'm just going to keep talking, and then you can just press pause or exit. I don't know. Yeah. I know, my voice is messed up, I know. Anyway. So there's all sorts of medical terminology that you might want to go over, like a hallux and a pollux and all that kind of stuff. Myology is the study of muscle and muscle tissue. Again, I'm gonna say it again. Yeah, why not? 3 types of muscle tissue: skeletal, cardiac, and smooth. 3 types of muscle fiber: fast glycolytic fibers, fast oxidative glycolytic fibers, and slow oxidative fibers. And the difference is the energy it runs on, the fuel it runs on. That's what the difference is. Know the difference between the type of first know the definition of kinesiology and what kinesiology is, which is the study of body movement. And eccentric contraction, this is stretch. Concentric is contraction. So I think you can make something up that'll help you remember that. And you should probably be remembering that already. So, functions of muscular tissue. The reason is, when it's really cold out here in Illinois, why you do jumping jacks outside is for heat production. They store glycogen, body position, stability, movement, all that good stuff. Action potentials. Remember action potentials? That in the somatic motor neurons move your muscles. That's how you move. Otherwise, you'd be sitting on the floor like a big blob. I do that anyway, but... So, isometric contraction, which means just hold the contraction. Basically, like if you're lifting dumbbells and you're holding your arm at a 90-degree angle, holding a 5-pound dumbbell, and you're just holding it at 90 degrees, that's isometric contraction because your biceps brachii is holding it there. So that's that. That should probably be enough of that. That probably. Let's see. Nerve and blood supply, highly vascular. You have an epimysium, perimysium, and endomysium. Epi, peri, and endo should already be ringing a bell. You should probably know what those mean by now, so I'm not going to go into what wraps around what. Remember, there's the muscles, then the fascicles, and the fibers, and the fibrils, and the actual sliding joints of the myosin, the actin, and the sliding filament theory, and then it goes down to the microscopic, to the sarcolemma and T-tubules and sarcoplasm. Myoglobin is basically hemoglobin for muscles. It's called myoglobin. And the sarcoplasmic reticulum, basically it just all changes for muscles, but it's the same general concept of muscle cells. Muscle cells can be multinucleated, like skeletal muscles are multinucleated and striated. Cardiac muscles, striated, but one nucleus. Smooth muscles, non-striations. And I think one nucleus. Oxygen consumption, you can go into oxygen debt, hypoxia after an exercise. That's why people pass out after excessive exercise when they're not used to it. That's why, like, basically you're running, and you sprint, and you're like, I can't sprint anymore, but you keep pushing yourself. That's why you're likely to pass out, because you're hypoxia, and then you take in a breath of air, and you're like, you wake up. And by that time, people are dumping water on you saying, wake up. That's happened to me. So, control of muscle tension, of course, your motor units, hypertrophy, atrophy, know the difference between the two. Now the bands, now we get all muscle proteins and all that good stuff. Myosin, actin, tropomyosin, troponin, dystrophin, ATP hydrolysis, power, M lines, Z discs, I bands, all that good stuff. A bands, H zones, which gets shorter, which never disappears, how does it work? So if you want to go, basically I say the sliding filament is like sliding around into an RPG launcher. I know that's not the greatest example. That's how I remember it. So what makes your muscles move? Nerves. That's what we are working on, right? So excessive nerve movement causes muscle spasms. Why do you feel sore? Because your muscles work so hard and your nerves are telling it. Why did you work so hard? So all that stuff. So basically nerves are just, we spend a lot of times on nerves. Oh, and back to muscles. One more thing is don't get caught like I did. It's the electron transport chain that makes 30 to 32 ATP when we're in the aerobic muscle cycle. Not the Krebs cycle. The electron transport chain makes the 30 to 32 ATP. Just remember that. And remember which fibers go into muscle fatigue fastest and all of that. So we're there, nerves. Now we did the spinal column, gray matter, white matter. White matter is because of myelination, gray matter because there's no myelin, unmyelinated axons. So basically they've named it based on what color they found it. Which is the smartest and the weirdest thing, I guess, that a scientist has ever done. And basically myelin is, of course, the sheet that goes around an axon, which delivers, and you should remember all of this. Dendrites take in the information, afferent neurons sends it up the axon, the cell body is known as the soma. Dendrites, the soma or cell body, to the axon. Axon goes up into the spinal column. Spinal column, posterior spinal column is sensory. So it goes up, brain integrated through the integrated, then comes back down the anterior spinal column, which is motor, and basically down the efferent neuron and tells your body what to do. It can either be somatic motor neurons telling your muscles saying run, because there's a rhinoceros charging at you, so move your goddamn legs so that you can get out of the way. Or it can be telling your glands, your eccrine glands secrete sweat. Simple as that. So let's not overcomplicate something that's too complicated. So that sounded dumb. Let's not overcomplicate something that we're still learning. We'll probably go back and review because we've been on spring break, and I just wanted to go over everything that we've done and that would have been on our midterm. We never took a midterm, and that's probably going to be on our final because they're redesigning our final, and we're not going back. And we're only going back in the fall, unless you're taking a class in the summer. So, yeah. So this turned out longer than I thought it would, and I hope you have stuck around. I tried to keep this sort of casual, as if we were in the library just talking this out. But yeah, if you want to listen to this like an hour before, half hour before the class, and then log on, I hope that this just sort of rings a few bells and that you can get back on track after sort of a week of decompressing. And I hope that your spring break went good, even though we're sort of confined to our homes under house arrest, so that we don't get sick. And I hope that y'all stay safe and had a good spring break, and I will sort of see you on Monday, or talk to you at least. So I'll see you later. Bye bye.